Hello everyone, thanks for joining, especially on Twitch. I want to give a huge shout out to people joining on Twitch, and if you're watching this on YouTube, thank you too. And yeah, so today I was hoping that we will jump on the Double Jump Academy course. However, the materials are not out due to time differences. I am in Europe, Central Europe, and it is 10 here, 10 a.m., and in Los Angeles it's 1 a.m. So yeah, there's some time difference, and I guess tonight we'll have some access to the videos. I will, however, only be able to show you guys on Wednesday. So yeah, tomorrow I won't be able to stream, but that's fine. We'll stream on Wednesday, and we will have everything ready for us for Double Jump Academy. Houdini for Games workshop, which yeah, sadly will happen. We'll kick it off on Wednesday. For now, we'll continue where we left off. Yeah, sorry for this inconvenience, if you may. Yeah, all right. So let's learn Houdini for Games episode 4. We are now working on it. I will go and watch some tutorials, and I'll be right back with you. Okay, so we will do something exciting. We will go back to our Boolean value from the side columns we made. If I may add, like right there, those columns that we made. And we'll go back right there. Now there's something called carve. It's a node, and we will see together how that works. We will check our point numbers, like right there. Let's go. Yeah, it's fine. Let's keep it here. Let's see our points as well. Actually, let's go in the front view. That's fine too. All right, and now the carves should be able to basically assign. We'll see it here live. Excuse me. It should show you, like there you see that one blue point there, that it's playing with our numbers. Actually, let's just show the points, and you can see it goes from the value of 0 to the value of 1, or like from the value of the lowest number to the value of the highest number. If we remove our points here, we should we still don't see anything. That's fine. We can have 2, as you can see here, one that goes from the beginning and one that we could assign it to go from the beginning, and one that goes until the end. And we see that they have a slight difference, and that is due to the point numbers, and there's a way we could go around it. However, they're not behaving super weird. We will see if it is the same thing that is happening in that. Yeah, they are behaving super weird, because here you could see that it's already on that part of the cylinder, and here it's acting completely different. We want them to be in sync. The reason for that is, like I explained before, the numbers here are not aligned. The 0 starts here, for example, and we have a different beginning point. They're not even the same numbers, and we have to be able to switch the data so it acts all the same on all 4 of them. We will see how that is done in a second. All right, guys, so we have solved it. And that is by just taking our attribute triangle from before, which have taken the values of the normals and applied it to the position. And that we've done the same thing. So we have our smaller circle, right? And we have our main circle. The main circle have went into a process where it got blasted. So we've ended up with 4 points only, like we've seen before. And then we have the smaller circle that have been added to the Boolean, basically, and it got cut out, and that is how we created our the main column that we have. And then so we have the other circle that we created to add the different columns together, like those here. I'll call them the ears for now. And so if we go back to that smaller circle and we follow that path it took, so we scaled it down. And before we didn't have this attribute triangle, I added that just now. And so before that, if you go back to the carve and you try to play with it, let me show it to you guys. All right. We're we're having some problems. Wait, let me check. Okay. And now if I play with the carve value, it's because it was on 0. Okay. Like we saw before, it is acting differently. Like it's not starting from the same point on all 4 of them. And what we need a value that unionize everything. So right now it's going out from a random point. It's counting from a random point. It has nothing to go back to. And what we did now is that we took that value that we created before, which says vector at normal. So take the values of the normal, the vector values of the normal, and equal it to the position. And this way we have a unionized way. That's my understanding. I could be wrong. Please leave it in the comments. Where we have basically created a way of data structure to unionize the points. And now if we go back to the carve and we check our values, we see that they should basically be starting from the same point. Let me just check if everything is working correctly. A bit of rotation afterwards, and then we have a boolean, and then we have the carve. Okay, and let's check if it's coming out from the same point. All right, so not completely. And although we just had it working before, something had happened. Let me check what is happening. I'll be right back with you. So we have done some stuff. I'm sorry for not recording them because I wasn't sure about the results and I didn't want to just pursue something that would hit a wall. So what we've done is we have taken the blast value, and so let me show you what that blast value is, and we have rotated it so it looks like this, right? So the spawn is in the correct rotation. And then we applied the attribute wrangle to it, just like we did before here, right? Because that value is basically on the right side, if you think about it, and that value is on the left side of the copy to points. And now it should work the same way we had it before. So basically we told it, hey, those are the points, 0, 1, 2, 3, which are 4 points. Can you please take its normal values and equal it to the position values and then copy the points? So we have our small circle, which has XY plane here, and it is connecting to scale down. So it got scaled a bit down, and then it got connected to the copy to points. And there was an issue before where we have had this ticked transform using target points, and now I unticked it, so it doesn't do that effect, right? I don't know if this would work, honestly. We will see now if it will work or not. Then we have that rotation again, and then we have the, now we will check if the carve is working after the Boolean value. All right, so let's check that out. Let's apply it. And let's see if it's going from the same points. And we see it is actually doing it. That's amazing. I feel like the rotation here could be bypassed because we don't need it to rotate again, because we already have rotated so before the copy to points, basically. So that rotation has no value. So basically we could just delete it. And now we have the Boolean value hooked up to it. And we have the carve, and it's actually it is working in the same way, where you could see the 0 point is in the same 0 point. Is it? Just checking if it is. Let's see. No, it's not starting in the same way, but it is, however. Okay, give me a break. I'll check it out again. It's not working for some reason. I'll check it out. I'll be right back. So we got it fixed, guys. There were some issues, but I'll show you how we turned it around. And I'm sorry again for not recording the process. I just don't want to foresee something that could not work at the end. So, but it worked for us, so that's great. So I'll show you how we fixed it. First thing we've done is that we realized that this Boolean was not working at all because it was coming from the same circle. And if we hook it up, I will show you how it will behave. you see that there's no boolean anymore, and that is the result of this. And this can only be changed if we it could be changed different ways, but since we have changed it to zx plane here, it's just, it needs an xy plane for it to work. So what I did is I split that value. So I copied the smaller circle and I made a new smaller circle with the proper orientation. And we made that boolean work. And because that boolean is working right now, we have that boolean that actually works too. And this allows this to work properly. That is the only thing that we've done so far and made this work. I hope I'm not missing anything. We just made sure that the orientation is working properly. We have fixed the orientation all on one axis because we had it a bit differently. So what we had before, we had the circle going this way. And now we made it all lay down on the ground. And this should fix things. And so, for example, when we merged all of them here, we should be able to extrude and have everything working as it's supposed to. However, this transform does not work anymore, so we will delete it. And we'll just go from the copy from there. All right, now everything is working. We have made the circle, like I said before, all flat on the ground because before they were on the Y, I think. They were going up this way. And we have, made them orient properly. We've added the attribute triangle that takes the cut out the blast and rotates it. And what's cool about the whole thing is, if we go all the way to the merge, like right there, let's get the top view for now. If we go here, and we can always manipulate this value and make it work for us. We can make it smaller. We can make it much smaller, like this, for example. This would look for sure better. And now we will continue where we left off. I'm very happy that it actually worked for us. Before it was not willing to work, and that is, I think, something to do with the normals. Like, for example, if we check the normals on this thing, let's check them. Let's just see how things are working. There are normals because there is no normal value, no attribute that reflects the normal also here. But do we have normals here? We have only position. Okay. But since we've said that the normal have the same value like the position, now we should have something that is pointing out at least. Just checking, just testing things. Let me see. Let's see after the boolean is done, after the carve is done. Okay, so I still don't get it 100%. What is the attribute triangle doing? All what I get is we're getting the values of the vector. We're not even getting the values of the vector because there's no vector value for the n. What we're doing is read, I think, in my opinion, from right to left, because what we're doing is we're saying the value of the position is the same value, the vector value of the normals, and this way we're taking those values of those 4 points here, we're giving them a normal that aligns them in a way, and this unifies everything for us. And yeah, now we have a thing that doesn't work anymore. It's always when I come back to it, it doesn't work anymore. Okay, give me a second. All right, so it's sensitive to a lot of things. One of them is the boolean. It's like, if the boolean is not working, so if we change the size here again, it will probably not work again. And we see it like it's starting from different points. 30 different points again. 33, basically the same point. 5, the same point. Okay, so it depends on the size as well. Yeah, I don't want to play with it too much because I just want it to work for now, just so we learn. But it's interesting that it depends on the size as well, not only the whole node thingy. Well, that's maybe because it's not yet procedural, like completely procedural. But maybe we could fix that later. For now, we're not going to worry about it. We just want it to work, and thankfully it is working. And yeah, that is amazing. Cool, then I'll be right back. I'll watch more tutorial and I'll be right back with you. Okay,
So we need something that resembles the corners, basically. And the way we could play with it is as such. So now we're taking only the corner value. And this will allow us a bit similar to Photoshop, to mask the corners in a similar way. So what we will do is add a resample to this. Resample allows us to take the actual points and like reduce them. So if I go to view this node right there, we could see with this parameter here, we could change the level of detail. And it should, why is it not working? Maybe here. All right, so this is the way it works. We will only need 3 points here, or 3 points to work with. And we'll see how that will keep going. So just keep in mind the resample takes, it makes things simpler in a way. And this is how you could mask things and spawn things in certain places. Okay, so we'll check how that will work out, and we'll be right back with you. Okay, so let's go, guys. So we will add a sphere now. So let me go back to my perspective viewport, and we will add a sphere. All right, so sphere, here we go. Here we come. So let's view the sphere. We see it has a lot of points. We don't need the point number. We just want to see it. Let's make its radius in 1 point a bit bigger, maybe just wider, basically. Yeah, let's do this, for example. Just like that. And now we will add a clip. So we will clip it from the bottom and from the top. We'll just see how that works in a second. We'll add one here, and we will add one here. And then we should be able, if we view this, we should be able to see that, hey, this got clipped now from the top, and this should now be clipped from the bottom. So you just have to change that primitive here. And in the sphere, we just want to make sure that it's a polygon mesh. All right, things are working well for us. And then now we need a way to, and focus now with me, gonna make a screenshot. So let me make a screenshot. So what we want to do is connect this to its to the different crop, the different clip we just created. So we need to first of all to transform it upwards, and we need to find a way to bridge. And the bridge itself is easy, but if you want to keep it procedural, there's a bit more work to do. That work is like we did before with the other stuff that we created with I think we did it episode 3 in the beginning, where we have added groups to select the edges, and we bridge them with that method, because we could be editing the sphere itself. We could be saying, hey, you sphere have less points, or etc. And this is how we could make that work. Okay, so let's do that real quick. First of all, this is the upper lid, right? Upper, and this is the lower one. So let's determine that right now. And let's keep them side to side. I think could be more pleasant to work with. I could be wrong. Let's see. So let's add the transform. And now we will connect it, of course. And we will take the translation a bit more out. I mean, what we could do is first see it and then press enter and just go like that. All right, this looks good. And the lower part is visible. Let's just template it, so just see it from far. Looking good. And now what we want is to add a group like we did before. So group, here we go. Just add that right there. And we will call the group a name, because otherwise we'll forget about it. So upper edges. Let's just call it like that. And what we need to do is a bit similar to what we did before. We'll select edges here. And what we will do is disable this and include by edges. So we'll enable that and unshared edges. And that should give us the lower lid part of it. And then we will copy that same thing and put it right there. Delete that connection, take it to the lower and connect it. And now it should basically have a different name. So we'll call this lower edges. Give me a minute. Yeah, lower edges. Looking good, right? And now we should be able to bridge both of them. And give me a second just to review how that's done. I'll be right back. Right, so we know how to do it now. So what we will do is merge the groups. So we will add a merge note. Here we are. I kind of like working sideways like this. I'll just merge it, but I don't think it's efficient, honestly. But sometimes you need to separate your work a little bit, make it look a bit different. It doesn't matter for now. So we will merge it. Let's see how it looks like. And then after the merge, we could add a poly bridge. So poly bridge, not bevel, but bridge. Right there, you connect the points, and now you have to tell the group name. So we had upper edges, and we had lower edges, right? Lower edges. All right. So and now we see that it could work. We'll view it right there. And we see that it's actually working and it's looking pretty decent. However, I need to know how this connection is being done, so I need the wireframe. So I will go with flat shade wireframe. Like this, we see that it's shifting, and that is due to this here. We could make it shift more or keep it on 1. This parameter here chooses how much it shifts, and this gives it divisions. For now, we'll keep the division to minimum, like maybe to 1, maybe let's keep it like that. And my stomach, or my body's telling me that I need to go to the bathroom. I'll be right back. So let's show you how that works in action. So I've added some divisions here. And now let's actually play with this a bit. It's something we should do a little more, actually. So if we, for example, to change the sphere itself and just like add some details here, we see how different this will look like. For now, we won't change it. We will maybe just change it from the bottom. That would work. All right, we won't change that. Okay, we see that it has a different value. We have the lower lip clip here. What we could do, however, is take that upwards even more, and what we could also do is actually scale it in here. And so if we to make this taller as such, we could make it. However, we also need another transform on the bottom lip as well. Okay, but it is working so far. It's looking good. I would definitely add a transform here, I think, just so we can have a scale factor. And let's give it a 2 here, because I think it would look better, and the 2 here as well. Yeah, okay. And now we will show you how we could spawn that into our resample. So we would be able to basically spawn that on this point, and then we will be able to boolean it. Okay, so let's check how that's done, and I'll be right back. All right, so what we will try now is to copy our last result, which is the pulley bridge here. Let's just take this upwards like as such and take our sample down like right here, and we will take this, put it right there just for organizing, and then we'll take the pulley bridge and basically copy 2 points, and now we'll be able to copy that 2 points. Here we go. And so we will take that value, put it here. Let's see if that works. Could be the other way around. I could be, yeah, it must be the other way around. So let's delete that, delete this, and we will add this one on the right and this one on the left. And now we have like way too big columns, and we can see that they have spawned 3, 6, 9, 12 times. And that is due to the shape of the resample that we've created right there. And so what we will do eventually is basically scale this down. So after the merge, after the pulley bridge, we should have a transform. And let's have that. So transform, no. So right here, tab, and we'll have a really nice transform here that would make it go smaller. So on the scale, we'll go with 0.2 maybe, 0.2, 0.2. and we will view that just to see how it works. Okay, looking good. I think it could use 1. So let's have 1 and 1 here. And in the height, I could see it going 1 again. And we can see that the tip here is acting up, and that is something we could change in the transforms here. One in the lower lid and the other one in the upper lid, and now we could see that we're having a better result. So let's go with 0, 1 actually, because that would bring the transform. That's too less, I think. Let's go with 0, 5 or 0, 4 even. All right, this looks good. And here too, 0, 4, right? And we will scale up from here. And this is our point, and now we'll check its spawning points. Looking good, right? And now we will take that copy that we created that is spawning in the wrong direction, but we will fix that because we basically don't need that transform, and here we have it. And let's compare it to our last result of here, and let's do that real quick. Okay, let's keep this here and let's check it here. Looking good. Let's just template it. Okay, so we see that the copy here is a bit too extreme. We will put it a bit down. Let's do that right now. Pull extrude, and the copy, yeah, exactly here. We'll make it into something that big. And then we will keep going, just checking a message. Okay, that's good. And then we will go right there. We'll check this out, and then we will do a boolean basically. So let's pull this down and add a boolean operation. Here we go. And we will connect the boolean right there from the column that we just created and from this one. And we will view it in action. We see that it is a bit too big, our columns. So what we will do is basically take our transform from here and give it a lower value. Probably we should do that. Let's see, maybe 0, 5 could help. And so we'll just do that, 0, 5. And here we can see those curves now happening around it. And what is also cool is we could on the go change our resamples so it could give us a better value maybe. So we will just do that. So it was 0, 5, 5, 2. We will see how changing that value could change things. For now it didn't, so let's go with the length. Here we go. Okay, maybe we should just view it itself and see how that is, what it is doing. So yeah, we could see we need to keep it to 3 points. However, we would like it to be a bit more, let's see, a bit more, let's see, this is not doing anything. We should not play with the length. I think the length should be the same. Level of details should change. But it is. All right, wait, let's see. What's maintain primitive order? What does that change? Nothing. Maximum segment length, maximum segment. Let's try to play with that. Let's see, a new message. Okay, just give me a minute. I'll be right back. All right, let's unpause that. Let's go back here and see if there's a different way. Subdivision curves, interpolating curves. That also does not work. Does it work here? Does it work here? No, it doesn't. Okay, let's not take that then. I don't know. This is way too sharp. Those points. Let's not play with that then. I mean, why is there level of detail if I can't change the level of detail? That's weird. Anyway, I think this is just a bit too harsh, honestly. And it's right on the corner. We could resize it, maybe. Maybe this could help. The carve, what could the carve do or help us with here? Can it maybe give us a better curve here? Just adjust it a little. Yeah, this could help, definitely. Okay, And now we will add the boolean again and check that out, how it would look like. All right, so we have those curves. Let's shade flat and let's remove points just so we could see the actual final product. All right, this is looking good. We have those nice sphere curves at the end. It's looking really cool. Yeah, we created that now. Looking really amazing. And so yeah, we will keep watching stuff and we'll be right back with you guys. So what we will do now is something a bit different. So we will go away from this column thingy and we will create a new thing that plays with a node called trace. Trace is really cool. So we'll play with that now. Let's just view it on only it as well. Well, what trace does is similar to what we did before in episode, I think in episode 2. If we pull our pure ref out and we actually take the pure ref file that we created, let's see if it actually saved it. All right, that's amazing. So as you can see, we were viewing those references and I've created this edge here, right? And if I go to the Photoshop file of that and crop it, we'll be able to trace that. We'll be able to just trace it, and that will be really easy way to create it without going into doing it using math. And I would love to know a way to maybe make it even procedural, but I think that will be the type of thing we will be learning today. So Photoshop is opening and I will just go to our file. It might be hard to find that file again. However, we'll just open it. I'll go to my documents. I'll go to my Let's Learn Houdini file. Here we are. And then we go to the profile here. So what we'll do is that we'll crop this now. And so cropping we'll do just like here and then here again. And we will take that up and that down. Let's see if it can trace black to white, but just in case it doesn't, let's make this black. Let's make the background white, and let's save this as JPEG inside of our file. So we'll call this side profile. Side profile, and at the end we'll add trace. So here we go. We have saved it. That looks amazing. Cool. We will take Photoshop down. We'll take pure ref, put it like here. That's fine, so you guys can see it for now. Okay, so we will now go with the trace node and be able to actually browse the file. Okay, so let's see. We're just gonna go to the file, and so we go to our document and we go to the side profile trace JPEG right there. And so we double click on that, and now we should be able to see some result, not completely. So we see some areas of error, but this could be due to a different thing. Could be because it's a JPEG, could be because it's a lot of different things. Let's see what we could do with the threshold. Okay, so it is definitely not working for us. What we could do is make this a PNG and see if it would make any change. So let's go with PNG and let's save that and press OK, and then we go back again. And now we take the PNG instead and see if that works. So far it doesn't really work, so threshold is also not working. I'm just gonna check. So we will just keep working with this until it works for us. So let's save it as PNG just as such and see if it could read it. So we will replace it now and press OK and then go back to Houdini and check if it's working. Let's choose it again and reload image. And now we have, if we go alpha, here we go. This works. Let's keep it for now. It worked for us, so that is nice. Let's just check the threshold, what it does. Yeah, how many points do we have here? Like 1 billion, right? Okay, so let's learn some tricks into how we could reduce that. One trick they show us is face T. So the same thing with the face T. and we apply it, and then there should be a checkbox, remove inline points, which calculates the inline points. All right, so this is inline. Why does it have to be so many points? So what it does, it just says point here, and if we do that, we could see that it is actually working. And there's a threshold as well, which we will be able to change. Maybe, okay, so what we will go is in the values here and just go slowly until it fits. Okay, a bit more. Feel like it could use a bit more. Okay. And now we have ended up with a couple of points and not a lot of them. Let's check the curve here if it benefits from any different values. Like, this is fine. This looks good. Okay, cool. Let's learn more tricks and I'll be right back with you guys. Let's record. All right, guys. So what we would need now that we have created a nice and lovely side profile as such, what we eventually want to do, our main goal, is to go take that puppy down there. Let's just take it right down there. And then we have that copy here. All right, let's go a little bit backwards. Like, we have this here. We want to create a side profile and we want to create it in curves. And so what eventually our main goal is to take those, what we just created from the image, and make it basically connect around this and create a frame, just to show what we could do with Houdini. Well, now, what I've learned, one way to do that is, let's just keep this thing a bit upwards here. And let's go back to the very basic Boolean shape we created. Maybe the next one, right? This one, maybe the one after the merge, this one. Okay, so let's take that one. And now we will add a circle. So let's add a circle again. We will take that circle and give it a bit of more divisions and make it a bit bigger. And keep it on ZX, actually on the ZX, not the YX. Okay, so that is fine. Just keep it that big. We'll give it more divisions. Looking good. And we will see now together why we have to do this. So far, let's just remove the points here. Okay, so we see this. And then we would need a way to to do the Boolean again. So we'll do a Boolean, a new one for our operation. And so let's take the merge and do a Boolean together with the circle. As we've learned before, we need to keep them both on surface. And then now we could choose what type of Boolean that we're looking for. And that is just make this a little bigger here. Let's try union. No, okay, we need first to view it. And then let's try intersect. No, subtract. Okay, so that is the Boolean we're looking for. And then after the Boolean is done, we will add a new node called ends. And the ends should connect our ends. Let's check on our wireframe. And I wish I know the shortcuts for those. Maybe I should look them up. All right, so we see that it had created some like really annoying geometry. What the ends does normally, like out of the box, is actually it turns everything into a curve, and we wanted to not do that. So let's just check one more thing. In the U, close U, we need it to be unroll. And let's check. All right, so I'm having a bit of different options here. We'll switch to the edges. Edges are 3, and we'll click shift and click here. And then we will blast that selection. So just with that, we do some cleaning, and then we will just blast the outer part. So not selected, and we will have that part here. However, why we're getting this value here inside, I really don't know. Is it due to the Boolean? Is it coming after the Boolean? Let's just check that out. Yeah, it's coming from the Boolean itself. Let me check. What could we do? What could we do here? I mean, the more points doesn't change much. However, with the merge here, maybe we need to split the groups, right? Yeah, that's the problem. It's right there. And one way to do this, let me try to understand it a little better. Group 2. What do we have in here? Boolean outside and Boolean inside, and then they merge. Can we somehow do those together, like Boolean together? Let's see if we could do that real quick. All right, so let's connect this group and just do a quick Boolean, like right on a separate level. Now we take their solid, their surfaces, their surface, and we basically unionize them. And how does that look like? Let's see. Are we getting the values we want? Group set B. All right, the surface as well. Let's choose the groups, I guess, and this should fix our problem, I guess. It still separates them. Okay, maybe we should do that prior to the grouping. So we have Boolean 1 and Boolean 2. Here we go. And now we basically no entries, exactly. Here too. And we unionize them. However, it's not connecting the points. And maybe that is due to... Okay, so what we need to do is take this one, and now it should unionize without... Alright, intersect. Alright, why are we having the colors here again? Alright, it's because I'm in wireframe mode, I guess. Yeah. How can I remove the points, the inner points here? The unionize should be the one, right? Shatter. And costume. Alright, no. Detect. No. Resolve. No. Union. All polygons only unchanged. No polygons. All polygons. I assume unique. Correct. Collapse. Okay. How can we bring both of them? How can we bring both of them together? All right, let me check. So we've basically tried to solve it now. I've returned a lot of the values back because we've started going... Results were a bit weird and confusing. I've just added a fuse so you could see this have been fused in to look like this. Just changed some of the values here and just until it's not showing that weird result anymore. So we have a fuse here and we have added the thing there, and now we'll connect them eventually and show you guys how that works. So we need a sweep node, so like sweet but sweep, and its effect is quite sweet. So this is how to remember it, at least for me. So I will connect the fuse, we forgot to fuse actually the face here, just to make sure everything is connected. So let's just fuse this as well. So fuse, make sure everything will be also connected. Just view it from the side so you know which one I'm talking about. It's the trace we just created. We will fuse it now. Just connect those nodes together and view it now together, and we will just add like a different value, and we will see points, and maybe we can manipulate it even more. Okay, now point, and it was a fine value. I just want them all to be connected so we don't have random numbers going around. So let's just check that actually. Let's go to the front view right there. So it starts 0 here, it goes up, the number goes up, the number goes up, 14, 15, 16, amazing. We just don't want it to go 0 back again. So it's all fused, all connected, right? Yeah, we have it. Looks good, guys. Let's actually switch it to perspective viewport. Looks good. Let's connect it to the sweep. So we have that sweep effect. All right, so and now let's change the value a bit until it works for us. So what we have done differently is that, so let's take this a bit down here, make some organizing happening. So let's go to flat shaded, uncheck the numbers of the points from the viewport and adjust it. And now let's just check the fuse, how big is it, so we see the best way possible. So you want the point of the thing that you want to revolve around to be the first point, and then the second input, and this is how you make it work. And now we will go into the sweep, and we see that we have a nice frame from the image we created, this image, this one, and now we have a frame from that evolves around a center, or a shape we drew now together. So as you can see here, basically the faces are turned over. That is something we don't want. One way to fix this is to go to the poly frame. We've tried this one before, just shortly, and now we're back to it again. If you remember, it's this thing with the tangent. So you basically enable the normal map, the normal name here, and you replace the tangent with the normal, and this way you get this, you get that frame inwards and not outwards, which is something you might want or might not want. Let's try to invert the value. Actually, invert, reverse. Is this a node? Yeah, reverse. Let's see how that works now if we add the reverse. Yeah, we could see that the faces are completely reversed. However, we're not getting any. Yeah. Anyway, so if you want it to work this way, let's bypass the reverse. This is how to see the difference, basically. If you want to face this way, you could do it by adding a polyframe before this here. Well, what happens if we put the polyframe right there? That would not do anything, right? It's not doing anything spectacular. It's just doing something here, and it reverses the face inwards. Could be something that we don't want here, and I don't know how to flip the faces on the go, unfortunately. Maybe there's an option here. I will check. So what do we have in here? We have surface shape, surface type, scale cross sections, max stretch. We have end caps group. Let's see. Let's not bypass the reverse. Let's keep it. So we see if we are fixing it here. Let's see, 10 max stretch. That doesn't change anything. This changes the size. Looks really cool. I really like this effect. It's very dope. And what else is there? Second input round tube. Okay, that's also giving interesting values. It's flipping the normals, of course, as well. Square tube. That's not changing much. Ribbon. That's not changing much. I bet it's used for different types. Alternating triangles, rows, and columns. That's just basically keeping everything to edges. End caps. Let's see what else is there. Rotation. That's one tab. Construction. Cross section order. Each cross section at all curves vertices. All cross sections at each. Okay, that doesn't change much, but I bet it changes the data. So that is something to keep in mind, that you could change things here. Polygons are at UV vectors, curve normal, x-axis. Yeah, here you go. You have more stuff going on here. We flipped it without the flip in the reverse. That is kind of cool. But what happens if we reverse the polyframe now? And we still are. we're still not really getting the values we want. We just want this thing to... All right, let's see. Z-axis won't change much. Attribute. I just wanted to... Yeah, let's keep it on curve normal. If we bypass this, it will be out. Okay. Tangent type. Central difference. Previous edges. Next edge. Nothing is changing unless we go here. Okay. What happens if we uncheck make closed curve orientation continuous? Explorate end tangent. Transform using curve. Okay, and if we bypass this one, we use the reverse here, we bypass this, it is not complying to us. Maybe there's another option for it to work. No, we're getting completely different results. I wonder how we could flip the normals. It must be a very fast way to do it though. Just like flip normals and it should work, right? I mean, why are we not getting that? Do we... What happens if I put the reverse? What happens if I copy the reverse, I put it after the sweep? What would that give us? Just wondering. All right. Here you go. That's how you do it. That's how you flip the normals. So keep that for future references. Yeah, this looks cool. I like it. And let's see what else we could do with this. So let me show you some cool stuff we could do with this. So we have reversed it, right? We could add more details to it. As such, we could make it thicker in this way, right? And what we could do eventually is take... So what is this copy doing? All right, so you could see we could use it as a bottom part. So if we merge the copy of the column and this together, we will get this type of column. Let's uncheck the point, and you see we have now a bottom for it. And if we actually copy that now, copy and transform, and we put it upwards, so translate in the Y, so make it like a 10. Too far, almost there. 9. Let's try 9. Let's try 8.5. As such, and this will give us now another column, and it will connect it this way. So if we, for example, to say give me 3 copies... Oh wait, this is going now way too high, right? So there's another one somewhere. Wait, I'm not sure now anymore. If we add 3 total numbers, no, it is actually working. That's cool. Okay, so we have a bottom part for this that is working quite well. Yeah, I really like it. And it is copying itself as such, looking good. We can add more bevel to it and etc. Now let's see how procedural our system is. So first I'll control S. Let's also view it as smooth, flat, smooth shaded. So yeah, this is how it looks like, looking really cool. It's all procedural. And let's check that. Let's put that to the test. I'm not sure how procedural this thing is. And so we have to revisit things. One of the things that we should visit is... Let's go right there. Let's do it quickly. Let's go back to our circles, right? So which group is this one? Let's make a new column and see how that works. Okay. So we have our circle. That is our main circle. It gets a blast here. So we delete all the points but those 4. And then we add a small circle. We spawn it on those 4 points. Now I wonder if we, for example, to add a copy here before it, what would happen if we say in this rotation, let's actually choose it. Like and keep this as a template, and let's say in the translation, just checking things out. Okay, maybe the copy should be after the... Yeah, like here. Let's see if we to add a rotation. No, not this type of rotation, but this type of rotation. Okay. Let's see. Maybe not though. Maybe the copy could be. Wait, let me delete that copy. Maybe the copy could be here in the blast. Like if we add a copy on the line, copy and transform. If we add it right there, and we get the actual axis here to show. All right, let's see. What are we doing? Doesn't look good. Let me see. All right, that is not working. It's fine though. Just delete, please. Thanks. Circle. Where's our circle here? It should show, right? Copy. Okay, it's showing now. With our copy to point, how can I add more points without breaking the structure there? Copy to point and then the transform. Okay, so basically I could add a copy to copy and transform here. Let's add 2 and rotate it here as such. And now just make it a 45. And we basically scale it a bit down, like 0.75 in all. 0.75. Yeah, now we see we have a different type of silhouette that we created. And now we have a transform and then a boolean, and the boolean is working, surprisingly, looking good. And then we have the second boolean that is now completely gone. And the end result looks as such. Could work for us. Let's see what happens afterwards. And so let's go back to the copy here. Things are different. They look different. Let's go back to our ends here. How's that working? Okay, how's the blast working? Completely gone, but we could select this by hand if we want to. And what we could do, let me try to think. Oh wait. The blast is from the ends. However, the ends are incorrect. And the boolean is correct. Right? Circle boolean. Then ends. And then we select. Let's select this by hand. Or should we select the blast by hand? I think we selected the blast by hand. Okay. What we could do is just select the proper ends. And double click, double click, double click. All right, and here again, here again, here again, and enter. How does that make the fuse look like? Makes it look weird. What we could do, let's see, let's take the fuse, let's reduce it. Let's take it, okay. Yeah, okay. You can see that there are limits to what we're doing. That is humbling, but we could fix some of the stuff actually. Let's take those small circles. Let's make them smaller. All right, and now we go back to our ends. We see that we could fuse things a bit better. If not, they are already better. Let me check. We might need to reselect things here. All right, here we go. We see that we have to. So let's just select things. All right, so the blast here we need, right? The blast had changed the ends. Let's see, it's click 3. And we select from 3. All right, let's see how that will work. Let's just select the inner parts only. Here again, here again. And now we should be able to blast on our own. Let's do another blast. See, I hope it works. Delete this one. And reverse. And now take to the fuse and see what happened. Okay, one thing we might be able to change is the resolution here. and see how that affects everything else. All right, what happens if I have much more resolution? Maybe less. How about 70? Maybe 60. Maybe we can see it's going really nuts now. 80. Okay. 90. 45. Nothing. So no, that's 12. Let's try 45. How does the scale affect everything else? Bigger scale, better results? Or how does 50 look like? How does 70 look like? How does 45 look like again? Looks better. Now we have the fuse, but the fuse is doing some really weird stuff. The blast is probably needs a check again. And then this, and this. Alright, and enter. And now we have a better blast almost. Polyframe again to do the normals. All right, how about the fuse here? Could we have a better value? All right, maybe we need another blast just to make this work, and it's manually now. Okay, and we just check this point, and this point, and this one there too, and we enter. And now the other way around. Okay, yeah, things are completely insane now. Yeah, it has limits. It has limits, but could be solvable if we just spend a bit more time on it. I think huge part of it are those small circles, like right there. Like this is very problematic. This thing. The bigger you make it or the smaller you make it, the more trouble you will face. And same thing if we to change here those copies. If we, for example, make them smaller. So in the 0.01, why are they all not changing together? All right, 0.6. Let's copy the value over. Wish there was an easier way to keep them conformant. All right, let's check our... I don't want to waste too much time, you guys, but let's see how that works. Delete that blast and go back to the ends. This is the same value, the same thing we had before. Like, there's no change. Ah, come on. All right, so copy. Why is this having an issue now? Ends boolean. Okay, but that is basically the same. All right, so now those got bigger for some reason. Okay, 1. Why are they so much bigger now? 0.5. Okay, that is super weird. Click it away, I guess. No, it's not working. 4. Okay, 0.5. Let's see if that works. Okay. Here we go. We have a different silhouette. How does that look like? Just reference it. Okay, it looks like this. Then it goes into the transform to the boolean. It has holes now. Let's see how that works until the reverse. Or the here, or the sweep. Okay, sweep's completely broken. I think we need to choose the blast again. Just trying different things. Okay, let's click OK here. Okay, go to fuse. How does the fuse look like? Less value or more, just so those points are gone. And then we have the reverse, we have the sweep, should work. The reverse here, Let's get the viewpoint. Yeah, okay, for now. Let's view everything together and they should have holes inside, right? Yeah, here we go. They have holes. Yeah, we have some flexibility, not too much because of that system here. We have to do a lot of stuff on our own. Okay, we played around with this. Let's continue to the next project. Let's keep learning, guys. All right, so what we will do is try to explain the carve thing better, just a little bit. So I created a new geo. It's anyway that we need a new project now. So let's view this. Actually, one way to, we have to hide it. Okay, so we will put this on the ground. So first of all, give me top viewport, then again, just perspective viewport. Why is it so slow? How to change this? All right, just keep going, I guess. That's how you change it. Okay, so what we would need is to align this thing on the ground. Align it on the ground as such. And let's check it from below. Whoa, what's happening? Am I really on the, like, the other side? I don't think so, am I? How to reset the viewport? Okay, so anyway, let's have this here. Let's make another circle. Actually, no. Yeah, you copy paste. All right, so we will make this be 0.5, just half the size, and we will make them copy over points. Copy to, no. Copy again. Copy 2 points, exactly. And we will make them go as such. All right, so we can see that they are being copied. However, it's completely wrong direction that they're being copied into. We will see how we could get that to work. So let's change. All right, so first of all, I need wires only. So just show me the wireframe here so I understand what is going on. Okay, so why are you not on the ground? You should be on the ground. That is wrong, and that is wrong. That should be the correct one. However, it is standing. Let's put the points down a bit. Okay. And let's switch them over. That is the mistake we're having here. That's why it's not working. All right, now it's working better. It's important to review those things. Let me sneeze, just give me a minute. All right, so let's keep going. We see that this is definitely on the wrong axis here. Let's try to change it until it fits. That is the proper axis. Cool. And then we will actually make it a bit smaller. Like, give me 0.25, right? Cool. And now let's see how the carve thing works. Carve. The carve, yeah. Crave, sorry, crave. Or carve, yeah, it is carve. Now let's see how it works together. If we to add another point, we see that they are all aligned to one direction and they are all acting in the same way. That is something we didn't want in the last project we worked on, because if we to have a screenshot of this, show you what happened that time. We wanted stuff to spawn only. Let me take another color. We wanted stuff to spawn only on the outside edges, and it was just not acting in that way. And you can see here that we will never be able to achieve this, because even if we change a lot of the things where the alignment is happening, you could see that all of them are aligned in that way. And if I may just add a red line here, they're all aligned this way. All of the circles are unified to align into that direction. All right, so if we to add a wrangle, our attribute wrangle right there, And let's put it, it depends if you want to put it here or here, but I think we would need to put it on the main one. I could be mistaken, let's see. And now we go inside and we say at n, at vn, so the vector of the normal, they are the same value as the p. And now semicolon, that should basically work. Let's see if it works here. Okay, we're getting an issue here. I think double equal, is that the way to go? At vn equals at p. Is it correct? Do we have a... Okay, maybe the wrangle should be on the other one. Let's see if that changes anything. Not really. Maybe the double equal sign is incorrect. And let's see if that works. Let's see if the orientation had changed. No. Okay, so we will actually go back and copy our code, the Vex code that we created in the wrangle. Right there. And we see it's in the attribute of the bigger on the points that circle should spawn on. So, and the code says v at n. Okay, so that is my main mistake here. So it's fine. We will learn from our mistakes. So v at n. Okay, so v at, an at is just, you can't have at vn unless you have made an attribute you called vn. Okay, and now this should do something which is not doing. So let's go put it in the other one. And here we go. We have the attribute going into a different direction. Let's try to add the planes into, yeah, this looks better. And so what we have now is that the normals are facing the outwards. Let's see, when we go here, and then we change the value, we can see that they're spinning in a different way. And now we can control by just spinning those parameters in a way where the points should be. So for example, on the outside, we can have them just go like that and maybe connect to each other. And so I think 0.51 should work. And we might need to scale them a bit up if we want them to touch. All right, a bit more up. Here we go. Now they're touching, and we can see that shape that we just created. Okay, so now we get it a little bit better, right? I have a better understanding of it, and the way to write the code is just for review for me is v vector at n equals at p, and the at is only something you could add if there was an attribute that it's called this way, because before my mistake was that I added at vn, and that is just not correct. Okay, we will save that and continue learning. Okay, so we learned a new thing. As you guys remember, we tried to connect those dots, but there is a different way where you don't even need to connect them, actually. What you could do is just have the same size, right, to... Let's 1.5, let's say 1.5, right? And we could actually connect the dots here with something called fillet, like a fillet. All right? Let's hook it up. Let's hook the fillet. And we have wrap last to first. And this way you could see that before it didn't connect this spot here, but now it does, because it could be used for other operations where it's not a circular shape. For example, it could be a rope, for example, but yeah, you have to check it if you want it to be a circle. Okay, so now we could even do some cooler stuff. For example, we could take our circle or the origin of it, and now we go deep here, we press 2 and we add a soft transformation. All right, and now we could take this a little up as such and play with the curve a little bit. This is looking cool. Now we have a different result a little bit, and it looks cool. And we'll keep going. We'll be right back. All right, so we have this interesting shape. There's nothing wrong with it, but I just wanted to show different ways we could play with fillet. I call it fillet. So we could like take that, make it blend a bit different, for example. We could also take convex option or a circular option. We will see that a bit later. You can put the order here. I don't know what this does, honestly. Left in UV, let's check what this could do. Yeah, this is the same thing we were playing with now before. Same thing we were playing with before. And here, I don't know what this one does. I'm just playing with the settings, basically. Here you go. That's also cool. But in order to know more how those things are working, let's just bypass that transformation. What we could do in Houdini is that we could convert the databases. What do I mean by that? So this is a polygon. We can make it go, or make it convert to a new religion, and that religion is called NURB curve. Of course, it's not a religion, but just for me to understand things and learn things faster, we will use the convert way to convert this thing into a NURB curve, like right there. Okay, so we will put it right there and hook it now to the actual copy input. And you could see now that the fillet here has different values. And if it already switched actually. And now we could play with this a bit more freely, and it will give us cooler shapes to work with. Let's see if this makes anything. You see that when the order is to 2, to 3, it smoothens the value a bit more. Let's add more points here. What is yeah, you could do all types of stuff. Looks really cool. Let's keep playing around with it a little more and check what else we could do with it. Yeah, a lot of cool stuff for now. Yeah, this is also interesting. We create like really nice stuff with it. Let's put this on 1 and this on 1. I just want it to work. Or -1 might work. Yeah, okay. I just want the values to be, there's an offset you could add. That's really cool too. You can create wheels with this as such, but just keep playing with those values. Really awesome stuff. Let's keep this to 0.5, honestly. Add this to -0.5. Such. Okay, looking good. What we could also do is duplicate the fillet, and add something called blend shapes. We will see what that will do now. Blend shape here and a blend shape there. And now view the result, and we could see that we could blend this value, and we could even take it up more. Wait, let's see. Okay, it's not working. Let's keep it on 0. This one, I think index is the one that we could play with a lot. All right, not this one, it seems. Okay. I need to check which one they were playing with. I'll be right back. Funny enough, I duplicated it and didn't change it. That was the reason why it didn't work. So if we, for example, to go here and create a convex shape, let's look at it, how this will look. Convex or circular, and this one will be convex, just to have difference of values. And now we could mix the blend and make it go crazy as such. Yeah, we could just view this one and see what we're doing. It's really cool. Like you could create new shapes. Yeah, looking really cool. Yeah, that is how you could play with this thing for now. Let's go like something a bit more extreme than this, like something like this, and let's play with the values here. What is the value that is not fitting with everything else? Like, why is it doing such weird things here? Is it not the same orientation, or do we need more order? Okay, and when the order changes, the blend loses everything. In V. Okay, that is going into the other direction. Let's see what happens if we change this width. Not much. Okay, what happens if we change this? Just wondering. Okay, now if we go here and keep playing with this, yeah, a lot of things are happening, that's for sure. Okay, good to know. I will keep playing with this until we see what else we could do. Okay, so yeah, it's kind of cool. Like if we to convert this back to a polygon now, so we could extrude it, for example. So we'll reconvert it to a polygon exactly, and we will add extrude, pulley extrude. Actually, it's called pulley extrude. Extrude. All right, and we'll put it down there, and we will go now and add add some values. So we're in perspective mode. That's amazing. Let's see how it's extruding. Why is it extruding this way? Way. Let's see. Span control, local control, extrusion. How can I control where individual elements? That's not working. Connected components. Point normal. Yeah, this is looking better already. But at the same time, not really. Okay. Let me see. I'll be right. All right, I missed one thing, which we basically worked with before, and that is to change the thing to global, local control. All right, I'll delete it. Do it again. Pull extrude. Okay. Let's do that, and let's connect this here. And in the extrusion, we go to, we use the transform extrude. All right, and we use the global thing. And now we put it up. Let's change our wireframe to flat shaded. Yeah, and then we view it. And then what we would do is also disable the normals for now and pick it more up, honestly, like -5, for example. We will add some division. Divisions can be added right there. So we'll add like 20. Here we go. And now we'll show you how to add some twist to it. Okay, that type of twist is not working. So let's twist it here by adding 45. Okay, and now we can see how we could make that column change on the go. So what we could do is here in the blend shape, go back right there and we start manipulating it so it works in different ways. Like you could see now that we're doing different things in here. Let me just zoom in for you. And if we to make this more concave like that, or go back to normal, which is the blend 0. And yeah, this is how it will look like. Yeah. All right. So there are flexible ways to do it. I just had the news that the Double Jump Academy course is the workshop is available now. So what I will do is I will end this video. Thank you all for watching. Subscribe and like and follow me on Twitch if you want to. I'll end the recording and we'll switch to the Double Jump Academy. I'll call the episode a new episode and we'll give it a new name. All right, thank you all for watching. I'll see you in the next one. Okay, so let's stop.